Good afternoon, students. Today I will discuss about the sublimation and deposition process. Then, after discussing this, I will discuss the graph about which show the state for various process. That means all process covered by that graph, from melting, then changing the temperature, as well as after that vaporization or evaporation also be explained. Okay, so let's start from sublimation. When we heat a camphor tablet or we take a naphthalene tablet, we will observe that the tablet automatically disappear after some time or some days for naphthalene, because this type of material directly changes from solid state to the gaseous state. So some types of matter are there, some type of substance are there which have less value of intermolecular force of attraction between the molecules inside that kind of matter, like camphor, like naphthalene, like ammonium chloride, dry ice. These type of material have very less amount of intermolecular force of attraction between the molecule of inside this matter. So when they absorb sufficient amount of heat, then every molecule inside this matter gain this heat energy and use this energy to overcome from the intermolecular force of attraction between themselves and become absolutely free. So every molecule directly converted into gases. And another thing is, so what is sublimation? If I ask about what is the sublimation, we can say that sublimation is the process. We can write like that: sublimation is the process. Sublimation is the process in which some kinds of solid molecule directly converted into gaseous state, some kinds of solid directly converted into gas without changing into liquid when some amount of heat energy absorbed. Energy gain. This is the process of sublimation, and which solid molecules or solid substance undergoes with this process, these solid substances are called sublimates. Sublimates. What is sublimates? Sublimates means this kind of solid materials which undergoes through this process, sublimation process. So the solid material which undergoes through this process is called sublimates. Example of sublimates are like camphor, 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 like naphthalene, like iodine, we can say dry ice. Dry ice means solid carbon dioxide, solid CO2. This is called dry ice. Okay. Ammonium chloride, NH4Cl, which is called ammonium chloride. They undergoes through this process, and this process is called sublimation. And now, what is deposition? If I am talking about the deposition, then what is deposition? Deposition during very cold days, or when the temperature of the surroundings is very cold, then water vapor or any kind of vapor directly converted into liquid. But some substance are there which, when converted from gaseous state, they releasing some heat. After releasing some heat, they directly converted into the solid state. And this process, which the opposite process of sublimation, that means directly from gaseous state to solid state, this process is called deposition. So we define the deposition like that: the process in which gaseous substance or gas substance some gaseous substance directly converted into change or into solid substance without changing into liquid is called deposition. Complete. So example of the deposition is when the carbon dioxide gas, we take heat from the carbon dioxide gas, then this carbon dioxide gas directly converted and form the solid state, form the solid carbon dioxide, and this is called dry ice. It is at very low temperature. It happens at very low temperature. And now I am showing you a graph, the change of the all state through the various process like that. This graph is also in your book, so try to understand this graph. This graph is showing like that. In the y-axis we marked as temperature, and in the x-axis we marked as the heat given. Okay, now when without any heat there have some ice, we consider it at zero heat given. there have some, and minus 20 degree centigrade temperature is there. So there are ice, they have an ice. We consider this various process for water molecule, or we can say that for ice to water and water to water vapor. Okay, we consider it for that graph. Now at minus 20 degree centigrade ice is stable. Now when some amount of heat is given to that ice which is in minus 20 degree centigrade, they increase their potential energy, they increase their kinetic energy and increase their temperature as well, but they is in solid state itself. So increasing heat, if heat given, some amount of heat given from here to here, within this they increase over temperature only, like that. This amount of heat is taken by that ice to increase their temperature from 20 degree to 0 degree centigrade. When he reached at 0 degree centigrade, then they does not increase their temperature by gaining some heat. By gaining some heat, say then this ice conserve this amount of heat, and after gaining sufficient amount of heat, this total heat, after gaining sufficient amount of heat, like that, this amount of heat, total this amount of heat, gaining this amount of heat, they use this amount of heat to increase their, to change their state from the solid state to liquid state. So in that case they are in solid state, in here they are in liquid state. So we can say that this is ice, and after that he gets converted into water. So from solid state to liquid state they absorb some amount of heat. After gaining this amount of heat, that means this liquid, this ice converted when into liquid. After that, if heat is given to that liquid, then this liquid again changes its temperature only, like that. Some gaining heat, they increase their temperature only. So from 0 degree to 100 degree centigrade till 100 degree centigrade, like that, they only change its temperature again and again by gaining this amount of heat. This amount of heat is utilized for only increasing the temperature, increasing the temperature of the liquid. Now after that, when he reach at 100 degree centigrade, then this liquid, like water, this water cannot increase the temperature by gaining some heat. They gain sufficient amount of heat and conserve it and utilize this sufficient amount of heat for overcoming from the force of attraction and becomes free for every molecule and gets converted into steam. After gaining this amount of heat, they utilize this amount of heat and water gets converted into steam. After converting into steam, if heat also given, then this steam increase their temperature, like that. So increase their temperature. When this steam, we give some heat to the steam, they increase their temperature. So for that process and that process, in that process, solid molecule converted into liquid molecule at a fixed temperature, and in that process liquid molecule converted into gaseous molecule at a fixed temperature. This temperature is called boiling point and this temperature is called melting point. And this amount of heat is utilized to change for the state from liquid to steam, liquid to gas, and this amount of heat is utilized for change from the state from solid to liquid. So this amount of heat is called, if that is Q1 for m mass of, if we consider m mass of solid molecule and this amount of heat is Q1, then Q1 by m, that means for unit mass of any substance for solid, when converted into liquid for unit mass, then the amount of heat required to conversion process is called latent heat of melting. So this is the latent heat of melting, and it is right like that L. This is the latent heat of melting, Q1 by the mass of the substance. Similarly, this amount is utilized for the conversion of from liquid to gas state. So if this is Q2 amount of heat and for that mass m, so this is the latent heat of boiling, and we can say that latent heat of boiling equal to Q2 divided by m. Is it clear to you, everyone? So this process will be happened, and here this process is only increase their temperature, and here we use the formula MST, where S is the specific heat capacity and M is the mass of the substance and T is the temperature change. But here and here we use the formula ML. M is the mass of the substance and L is the latent heat of the substance. So for that case, from ice, temperature increasing of ice, temperature increasing of water or liquid state, and temperature increasing of gaseous state, we use the formula MST, mass into specific heat into temperature change. And when the conversion of the state happens, then we use the formula ML, that is the mass and latent heat of that matter, that means solid, maybe solid or liquid or gas. Okay, so thank you class, thank you for cooperation.